Today, I want to do the bacterial identification. So before that, I want to tell you about the theory. The theory of bacterial identification is bacteria identify proteins linked by morphological and biochemical tests, supplement as needed by specialist tests such as serotyping and antibiotic inhibition pattern. Newer molecular techniques permit species to be identified by their genetic sequence, sometimes directly from the chemical specimen. First, I want to do the sample preparation. So I need to pick up the pair of rubber gloves in the upper drawer. And after that, I want to pick up wire loops to make a sample from the culture dish. And then I want to pick up the one or better colony in the dish. After I pick up the colony bacteria, I want to transfer the bacterial colony to the microcentrifuge tube by using the wire loop. After that, I want to add the digestive enzyme to the sample. So I need yellow micropipette. And after that, I take the micropipette for several hours. Now, microcentrifuge tube must to heat inactive the digestive enzyme into my water bath. After a few hours, after the microcentrifuge tube at the water bath for a few, so the delicious enzymes are denatured and inactive. Now, microcentrifuge tube to the centrifuge. Now I want to spin down the cellular debris for removal the sample. So I close the centrifuge lid. After a few minutes, after a few seconds, now unknown debris has been spun down. Now I want to pick up the microcentrifuge tube to transfer the supplement into the PCR tube. After the sample preparation is complete, now I want to add the PCR master mix cellular to all tubes, so I need red cap master mix bottle. And now I want to set up the positive control reaction, so I pick up the thin cap positive control DNA bottle. After that, I pick up the blue cap iodine water bottle to get the negative control reaction. I open the PCR machine to transfer the PCR tube. Now I close the PCR tube and the procedure is is running PCR application. After it done, I want to do the PCR purification process. Now I pick up the yellow cup buffer bottle to set up the micro concentrator column. And then I pick up the orange transfer to edit the PCR product to the column and discarding the tip. The tube that contains the PCR sample has positive control and negative control. So I want to put it into the eyes. And the orange tray to allow the column into the centrifuge. To edit the Now I want to close the centrifuge and wait for 15 minutes and pick up and remove it into the centrifuge. After DNA was fed into the column, so I need to losing it into the new tube. So I pick up the orange tray to edit new collision, new tube, and I pick up the investing column to transfer the buffer solution and discarding the tip. Now I don't need not longer need the first solid collection tube, so I pick up the orange tray again to discard it. Now I want to centrifuge the assembly to collect the DNA into the collection tube. So I pick up the orange tray again. After it balanced, I want to close the centrifuge and wait for 2 minutes. And I remove the tube into the tray, and the DNA was collected into the collection tube, and the column is not longer neat, so I want to destroy it. Discard it. The column. Now PCR product was being purified, so I want to do the DNA sequence. I pick up the blue cap distilled water bottle to dilute the DNA produced to increase the volume. And discarding the tip. The green and blue stick tube have contained the PCR reaction mix, so I pick up the stick tube to edit the purified PCR product. To each tube. Now the tube have ready to PCR application, so I pick up the PCR machine, open the PCR machine, and transfer the stick tube. And now I close the PCR machine. Now the result of PCR applications. After it done, I want to do the DNA sequence. So I pick up the orange tray to load the automatic sequence. So I open the DNA sequence machine and allow the tray and pick up the tray into the below machine. And then I put it the ingredient above the orange tray to view the DNA sequence animation. Now it is sequence. After the DNA sequence is done, I want to see. After that, lastly, you need to sequence analysis. Now I want to open the computer screen to identify the bacteria. First is sample A flown from lymph nodes. Pathogeny. Sample 2 is stock sample. And now I want to try to identify the stock sample. Third is urine sample. Fourth is blood sample. the patient. Seminal time. The fifth sample ini. And the lastly is stock sample. There are 6 samples. Then I identify the bacteria.